Hi, I'm Dean Bushmiller with Expanding Security, and this is Industry Cybersecurity Models and Frameworks. You'll see here that it says models and frameworks, and we're just going to talk about frameworks here for our particular industry that we are in. We're going to take a minute to look at all the different ones, and you'll notice if you're looking at the mind map right now, it looks a little different because I've replaced each one of these components with the best examples that I could come up with of the different industry-specific cybersecurity frameworks that work for most of us, not all of us. And there's going to be some that are missing out of this whole set here. So let's zoom into the concept. Okay, what's a framework? Well, we've got a particular kind of infrastructure. Maybe it's critical infrastructure, and this is a definition for developing that protection of it. But more importantly, it builds a common language that can go across the particular industry. Why that's important is because then for people in that industry, they can have mobility from one job location to another, but it's always about expressing the cybersecurity risk. We need to get some outcomes, and each one of these industry-specific things will have some fine-tuning that says, hey, this is where we're different than that particular industry, and we need to pay closer attention to this particular thing. But it's all cybersecurity outcomes. Some are better at giving examples of guidance to achieve the outcomes than others. Some give very prescriptive advice like PCI DSS. We're going to map ours, every one of the ones that you're going to see, we're going to map that back to the NIST Cybersecurity Framework version 2 and the functions that are in there. And I'm going to go over those in a second. So why are we mapping to this framework? Why aren't we using like ISO 27001? Well, because 27001 costs money. If you're trying to learn this, you don't want to go out and buy the standard. So that's why I mapped it to this. But you could just as easily map it to the ISO 27001. And it would come up pretty close to what we've got right here. So that's the only reason that I chose this, was because from a learning opportunity, I can't give away an ISO document to you. And in the learning, you probably don't want to buy one. So what does that framework look like? Well, when I look at this, there are 6 major sections. Most of the documents that we're going to talk about do not talk about govern. They talk about the other ones, and they talk about them in a different way, but they don't talk about govern, and I will point those out as something that's different. For govern, what does that mean? Well, we'll set up our strategy and our hierarchy. There will be people that we know inside of this organization. We'll define the organizational risk management policy. This is the kind of risks that we take. These are the kinds of risks that we don't take. If you don't know, ask somebody above you. If they don't know, ask somebody above them, because we will make risk decisions, risk management decisions at the top of the organization. Then we'll assign roles and responsibilities for oversight. So you will have somebody that is Chief Information Security Officer, and they'll be separate from the Chief Information Officer, because those are conflicting roles, and that's why we have roles and responsibilities, so that the oversight is correct for cybersecurity. Next, we identify things like physical and software assets, because they are 2 different assets. It's not even including the data that we're talking about. Then we assess the organization's risk and vulnerabilities. We have a vulnerability management program. We have a risk assessment program at the identification level. Then we'll look at how the data flows through the organization. Where does it come into the organization? What systems does it go through? How is it transformed in those systems? At intermediate devices, do we send it out to somebody else for processing and bring it back? Maybe a SaaS application. And we're responsible all along the way. By documenting those flows, we say we know where our data is going, and we're responsible for identifying changes in that data, or maybe even data spills. Then we put controls in place, and that's called protect. So we're going to look for identity management and access control at the very top of this level, but then we're also going to do data security and encryption technology to make sure that the data that is at rest will be protected. We'll maintain that protective technology and infrastructure. That means that we're going to do updates to things. That means that we're going to do software and hardware updates. That means that we're going to do hardening guidelines as they come out, or new hardening specifications as they come out. Then we'll do detection, which monitors for anomaly and security events. We have people on staff that are continually reviewing the output of controls. We'll implement a continuous monitoring capabilities that might even be SIEMs, SOCs, SOARs. It all starts with an S, right? And we'll maintain detection process for rapid alerting. How do we tell somebody? Do we just go, hey, the internet's broke? Or do we have a help desk that takes care of us? Do we have a security operations center that's working for us? Next, we'll respond to this. That will be the execution of the incident response plan. You have a plan, right? Everybody knows about that plan. They've been trained on that plan. They know what to do, I hope. Then we perform analysis of detected breaches. What happened? How did it happen? Where did it start? Where did it go? How bad was it for our organization? And then we put in controls after the fact to stop those threats, to basically recover from that stuff in the response. But that brings us to the recovery section, because the two get really closely combined together. In recovery, we're looking at the recovery plan for resilience so that the mission can continue to be delivered. We execute the restoration of the systems and the assets. Maybe we fail over to a secondary location and now we have to fail back. And finally, we communicate with the recovery status to the stakeholders so that they can go out into the public and say, everything is good. Or is in the old Animal House movie, remain calm, remain calm. Okay, but you get the idea. These frameworks that we're going to talk about, I'm not going to go into that level of detail with each one of them because this is the set, and then we'll compare to the others and see how they're different there. What industry-specific implementations did I choose? Well, I chose each one of these because this covers a lot of really good examples. Is it all of the different industries? No way. I mean, when I went and did my initial search on this, I said, what are these 60 industries? What are these 15 commandments? 10 commandments. Look it up. It's a Mel Brooks movie. Anyway, the idea is that it was just so overwhelming to me. So I was like, okay, which ones could we pay attention to, see significant differences in, and understand how it would apply to us if we don't have an industry-specific set of frameworks that are out there for us. So it's our job to map the industry framework to either NIST or the ISO 27001. And that's what we're going to do next. These frameworks are important. They're very specific, and they, in a lot of cases, because there's regulations tied to them, we can't use AI to help us with this. We can't use AI to tell us what it is. We can't use AI to tell us if we're following it. AI is not an auditing tool. It's a token spitter. It's really good at spitting tokens, but that's it. It is not a sufficient replacement for a physical auditor because there is litigation tied to the back end of failure in cases of total negligence that causes harm. And that's why AI does not fit within this. Maybe it will in the future, but as of 2026 February, not so much. So I hope you'll join me for the entire presentation.